Here we are with our last video for Chapter 1. We have the previous home run king. Here are the number of home runs that Hank Aaron hit in each of his 23 seasons. They give us the data for each of the seasons and tells us to analyze the data presented. Now notice all it says is to analyze the data. Very broad. You need to know when you're asked to analyze data or describe data, that means you need to draw a graph and then go through SOCs and make sure you're giving context. So the first thing I'm going to do to draw that graph is I'm going to take this and I'm going to put the data in order. In this video I'm going to show you creating a box plot. Now for this set of data with 23 seasons, you kind of open to what you want to do. You could do a dot plot, you could even do a stem plot since you have some different values. You can do a histogram, though the histogram and the box plot both are losing a little bit of your detail in it, but they both give you a good visualization as well as help you with describing the distribution for it. So just to try looking at a different graph, I'm going to show you a box plot for this one. And we're going to do the box plot by hand, though your calculator does do a box plot as well. So to get your box plot, you need your 5-number summary. Now remember, your 5-number summary includes the minimum value, your first quartile, the median, your third quartile, and the max value. And again, this is something else that you can find on the calculator, but again, I'm going to show you how to do this by hand right now. So we have 23 seasons. The minimum value is the lowest value, so we have our minimum of 10. The max is going to be the highest of the 23 seasons, so our max is 47. The median is going to be in the middle, so in 23 seasons, if I cut that in half, I would have 11.5 seasons, so I'm going to count to the 12th season. And that's right here at the 34. Now once I look at this season, I have 11 seasons below that. So my Q1, I'm going to take half of that. So here if I go to the 6th season, or 6th highest, not actually the 6th season here, it's when they're in order. That is going to give me my Q1. Now again, just like we saw in the NBA example that we did when there was 30 seasons, half of 30 is 15. So I wouldn't have this value that's right here in the middle. I have to actually take the average of 2. So let's say if it was these two, I would be taking the average of 34 and 38. So keep that in mind. If you're ever between two, you have to take the average. And same thing down here in your quartiles. Let's say there's 10 left down here. You'd be taking the average of the 5th and the 6th value. So I'm going to do the same thing here. So I get my Q3 is at 44. Now the box plot comes from this 5-number summary. I'm going to start with a number line because that number line is going to allow me to keep a scale. Now I chose to go by 5s just because it seemed convenient. There's no real rhyme or reason. You could have gone by 2s, you could have gone by 1s if you wanted to. Just something that's going to give you a nice scale so you can make sure you stick to that scale. Okay, at our minimum, we draw a short hatch mark. At our Q1, oh, I wrote Q1 there. It was 26, sorry. At 26, I'm going to draw a longer line. Median was 34. I'm going to draw the same as the Q1 line. This is creating our box. Q3 is going to be the same as well. Now these ones close to make our box. And then our last one, this was 45, so 47 should be about here to end our whisker, and we're going to connect the whiskers to our box. Make sure it's clear where your box and whisker plot is. Sometimes it's nice to do those in different colors. So remember, this is breaking up into quartiles. So from the minimum to our Q1, this is 25% of our data. In other words, it's 25% of his home runs, his seasons had between 10 and 26 home runs. 25% had between 26 and 34. 25% had between 34 and 44, and 25% of his home runs, or his seasons, had between 44 and 47 home runs. That is a quarter of the time he was playing, he was hitting between 44 and 47 home runs per season. Pretty amazing. Okay, so that's our graph for this. Now again, we have to go through SOX to describe the data. So our shape, it's not always easy to see our shape from our box plot. So if you're doing this in a calculator, it's nice to maybe look at a box plot and then also look at a histogram to help you get shape. But with this long whisker here, that usually is going to look more like a tail on a histogram. So this is likely to be skewed left. So I said there appears to be left skewed set of data showing that in most of Hank Aaron's, 75% of them, again going back to this idea of quartiles, seasons, he hit 26 home runs or more. So that's our shape. Now for outliers, we're going to try that IQR rule. So it's 1.5 times IQR, which stands for the interquartile range. Excuse me. To get our interquartile range, we take our Q3, which was 44, minus our Q1, which was 26. That gives us 18. Now we're going to multiply that times 1.5, giving us 27 home runs. So we're going to go back to our Q1, which was 26, and we're going to subtract out that 1.5 times IQR. So we're subtracting out 27, which gives us -1. And then we're going to go to Q3, and we're going to add 27. So if he was somehow able to hit a negative home run, that would be considered an outlier. -1 or lower would be an outlier over here on this end. And if he ever hit 71 or more home runs in a single season, then that would be an outlier. Neither of those things have happened, so this tells us that there are no outliers. Now for our center, we already found a center here of our median. So we had a median of 34 home runs. So on an average season, Hank Aaron was hitting 34 home runs. And then finally our spread, we would say that there was a spread. I would use our interquartile range. Since it is skewed, interquartile range is less affected by that skewed. It's more resistant to the skewness. So we would say we have an interquartile range of 18. I hope this helps you to explain and analyze your data.